Hello friends, welcome to yet another interesting session where we'll be looking at chemical bonding. Please enjoy as we dismantle this topic. Okay, so chemical bonding is just the formation of bonds between two or more atoms. Okay, so atoms form these bonds for stability. So they try to form these bonds with fellow atoms just to gain that stability. Okay, so we have got two types of bonds that we're going to look at in this session, but there are more types of bonds that we have, but this session is specifically looking at two types of bonds, and these are ionic and covalent bonds. So these are the two types of chemical bonds that we are going to invest time in. Okay, so let's dive into each one of them. Okay, so we have number one, ionic bonds. So these ionic bonds occur between metals and non-metals. Okay, so an ionic bond is just an attractive force between oppositely charged particles. What are these particles? So we're talking of positive and negative charged particles. How do they arise? Okay, so when an element or an atom loses an electron, it gains a positive charge. When an element gains an electron, it possesses a negative charge. So these two charges means the positive one means an element has lost electrons. The negative charge means an atom has gained an electron. Okay, so this is what this point is trying to emphasize here. Okay, well, let's look at one critical example that will give us an understanding of ionic bonds. So we're going to look at a common sodium chloride, the one we call salt. How does this bond form? Okay, so we shall start with sodium. Sodium, we understand that has got atomic number of 11, and chlorine has got atomic number 17. Okay, so now let's try to come up with the electronic configuration of sodium and chlorine and show how these ions, charged ions, come about. Okay, so here I'm putting my sodium. Okay, sorry, let's do some rubbing so that we clear our board. Okay, so let's draw the electronic configuration of sodium. Okay, so we know that sodium has got one electron in its outermost shell. Okay, so to reduce on maybe confusion, let's draw the hole on it. So we have that, and also we have got 8 in the second shell, and in the last shell we put one electron. Then for chlorine, it has got 17 atomic number. So 2, 2, 2, 2. When you count that, that's 10, so we're remaining with 7. 7, that is 6, and that is 10. So what happens here is that the sodium, okay, has got one electron in its outermost shell, and chlorine has got 7 electrons in its outermost shell. Okay, so for sodium to gain stability, it is going to give the electron that it has in its outermost shell. Why? This is because it is easy for sodium to lose one electron than gain the 7 that are needed for it to gain stability. Same happens to chlorine. It is not easy for chlorine to lose all these 7 electrons, but easy to attain 1. Okay, so I'm showing it there. So this electron has come from sodium. It is easy for it to gain. Okay, so what has happened is that sodium has lost one electron. So this is what we are talking about. So it has lost one electron and it possesses a positive charge. So that's what we mean. Okay, so chlorine has gained 1, and we said when an element gains an electron, it possesses a negative charge. Okay, so we know, you and me know that opposite charged particles might attract. So we have the positive and the negative. So these two charges have got the capability to attract and form a bond. That's how we come up with the sodium chloride, which is this bond here. Okay, so there is an attraction. So that this is why we qualify these two elements when they combine as under ionic bonds. So they are classified under ionic bonds. Okay, hope that has been gotten. So sodium chloride is under ionic bonds. Why? Because there is formation of ions and there is transfer of electrons from one element to another. So that's all what we're talking about here. Okay, I think that's all for ionic bonds. Let's dive in and look at covalent bonds. So under covalent bonds, we are saying there is mutual sharing of electrons between atoms. Okay, so this one does not involve the transfer of electrons, but it involves the sharing of electrons, which means each element that is involved in the bonding, okay, also participates or gives or shares an electron, so that there is a formation of a bond. Okay, so there is no transfer, but there is sharing. Each element shares an electron or electrons to form a bond. Let's look at this example. So chlorine exists as a diatomic. So when chlorine atom and the other chlorine combine, they form a bond. So what happens is that this chlorine gives that electron, and also that, so when these combine, they form a bond. So each one participates. So there is that formation of the bond. Okay, so there is one electron from this chlorine and also one electron from this chlorine. So you can show it in this way here. Okay. Okay, so like that. So these two electrons, so when you draw a line, it simply means two electrons, one from this chlorine and the other from that chlorine. The other example we can talk about is the bond between hydrogen and fluorine. So hydrogen gives that electron, and also fluorine gives that, so that there is that mutual sharing of electrons. Okay, you can also show it in this manner. Okay, fluorine. So each element gives something for the formation of a bond, rather than what happens in ionic bond, where completely the electron is transferred to the other element. Okay, so these covalent bonds are further classified according to the number of bonds that a molecule or compound can form. So we have number one, single covalent bond, we have double covalent bond, we also have triple covalent bond. Okay, and let me use a different marker. Under single covalent bond, we can give an example of water. Okay, we know that is a single bond. Then double covalent bond, you can give an example of a bond between oxygen and oxygen. Then triple covalent bond, you can give an example of a bond between carbon and nitrogen. So based on the number of bonds, that's how they are classified. Alright friends, hope you are enjoying. So combined bonds can further be classified based on polarity. So they can be further be classified based on polarity. Okay, so based on polarity, we have got two major categories. We have polar covalent bonds and we have non-polar covalent bonds. Okay, Polar covalent bonds, this is a type of bond where we have an equal sharing of electrons. Okay, then we talk of non-polar covalent bonds. This is where there is equalness in the sharing of electrons. So, example of polar, we can give of a water molecule, okay, where there is an imbalance in the sharing of electrons. Then, on non-polar covalent bond, we can talk of, so this non-polar covalent bond mostly occurs between the same atoms. Let's say between hydrogen and hydrogen, also fluorine and fluorine. Okay, so there is equalness. Each element participates in sharing. Okay, now I believe by now you have a question to say, how do I tell that this type of bond is covalent or non-covalent? How do I tell whether it is ionic or it's all this? Okay, so we are going to dive in and look at electronegativity difference and type of bond. Okay, so electronegativity is just the measure of the ability of an atom to attract electrons. Okay, so that's the force that an element has to pull electrons. That's what we're talking about, electronegativity. Okay, and as you can see, this illustration here of partial periodic table, okay, we can see here how these arrows are shown. So this just shows how electronegativity increases. So it increases from right to left of the periodic table. Okay, so when you look at this side also, we've got an arrow running from down up. So also here electronegativity increases from down upwards. Okay, I believe even the numbers are very clear to say there is an increase in the numbering, if you can see. Okay, so these are electronegativity values. So there is an increase, I believe you can see. Okay, even down there you can see this is 2.8, 3.0, 4.0. So this is how they increase. In other books, when you look at books, they draw also an arrow between here. Okay, there's an arrow that runs diagonally there. Okay, so we have got, so these bonds, when you talk of non-polar and polar and also ionic, we have got values that they possess when they are under these types of bonds. Okay, so when the bond is less than 0.5, it is non-polar. When the bond is between 0.5 to 1.9, it is polar, covalent bond. If the bond value is above 2, it is an ionic bond. Alright, so now when you talk of electronegativity, this when you talk of the difference, it simply means there is some subtraction that is happening. When you have two atoms bonding together, then you subtract the two values that we have in here, you should be able to predict the type of bond it is. So let's run through here. Okay, follow closely as we do the math here. Okay, so we have the bond between carbon and chlorine. So we want to tell what type of bond is this. Is it ionic? Is it polar covalent? Is it non-polar covalent? Okay, so let's utilize these videos above here. So carbon, what value does it have? Okay, so it has 2.5. Okay, then chlorine, okay, has got 3.0. Okay, right. So let me just write it correctly, starting with the big value. See, 3.0 minus 2.5. Okay, so then let's find the answer here. So 3.0 minus 2.5 gives you, let's do the calculation. So that's 5, 0. Okay, so we have 0.5. Look at your values that you have there. Where is the 0.5 falling? Okay, so we have 0.5 to 1.9. Okay, so this type of bond, it is what? Polar covalent bond. So it is polar. Okay? Yeah, so let's, I believe by now you've already predicted the type of bond sodium chloride has, this type of bond here. So let's go ahead and predict. Okay, so sodium has got, okay, 0.9, chlorine has got 3.0, so let's go ahead and write. So 3.0 minus, we have 0.9, what do we have? Let's do the calculation. Okay, that's 0, then you have 1, 2.1. Okay, you have 2.1. So where is the 2.1 falling? I believe you can see it is above 2, and this is 2.1. So this type of bond is an ionic bond. Okay, let's go to the next one. Okay, oxygen has got 3.5 and hydrogen has got 2.1. Okay, let's go ahead and write. So oxygen has got 3.5 and hydrogen has got 2.1. Okay, let's go ahead and find our value. Okay, so 3.5 minus 2.1, so that is, we have 4.1. Okay, 1.4. Where is that falling? Okay, so it is falling between 0.5 minus 0.5 to 1.9. So this type of bond is also polar. Okay, so we don't have any non-polar. Let's go to our examples that we gave here. So we had hydrogen. So let's get that bond and find our value. So let's use fluorine. There we see the type of bond that will give us. So fluorine 4.0. Okay, minus 4.0. That gives us a 0. And where is that 0 falling? It's falling under less than 0.5. So this type of bond qualifies to be a non-polar bond. Alright friends, this is what I have for you today. I believe you've done your best to understand. So if you have any questions, please drop them in the comment section and we'll be able to address them. Otherwise, thank you very much. I hope you have